We're about to do 6 more trig identities real quick. Hopefully you've learned a few things over the last few days. Cosine squared equals cosecant squared, cosine squared, over tangent plus cotangent. If I'm looking at this particular problem, we're actually going to start with the right-hand side on this one. The right-hand side looks a lot more complicated. What we're going to do is we're going to change everything to be sines and cosines. So I have 1 over sine times cosine all over sine over cosine plus cosine over sine. And now let's simplify the numerator to be cosine x over sine x. And then after that, probably what I want to do is get a common denominator of the denominators. So if I get a common denominator of the denominators, that would be sine times cosine. So I'm going to multiply this one by cosine over cosine. I'm going to multiply this one by cosine over cosine. And I'm going to multiply this one by sine over sine. So that's just kind of what's going to happen in the next step that I do. So as I go about doing this, I end up with cosine squared over sine times cosine. Then I have sine squared over sine cosine plus cosine squared over sine cosine. Now, since I have a common denominator of the denominators, like in a complex fraction, all of these things cancel. I needed another x there, sorry about that. But all those things cancel, and I end up with cosine squared x over sine squared plus cosine squared. Now, one thing that we have to remember, and hopefully we know by now, is that sine squared plus cosine squared is 1. So this is just equal to cosine squared, which is what the left-hand side is. Number 2, I'm going to work with the right-hand side, but this is a case where I'm allowed to kind of manipulate both sides as long as I don't cheat, so to speak, like multiplying both sides by something or something like that. But the left-hand side, I know this equals 1. So once I get to 1, then I can pretty much be done. So what I'm going to do is I'm going to look at the right-hand side, sine to the fourth minus cosine to the fourth. What I'm going to kind of remind ourselves of is when I have something to the fourth, I can still like treat it like I have a difference of 2 squares, or it's something that kind of looks like that. So that's something that we already kind of talked about. So if I manipulate the right-hand side, what I'm going to do is this sine squared, sine to the fourth minus cosine to the fourth is the same thing as sine squared minus cosine squared times sine squared plus cosine squared. So that is just factoring that as the difference of 2 perfect squares. Now this ends up being even simpler than I thought, because these cancel, and I didn't even have to simplify this side to be 1, because sine squared plus cosine squared is exactly the left-hand side. But I could have, if I wanted to, and made both sides 1, and that would have been okay. Now let's look at problem 3. Problem 3, I'm going to look at the left-hand side. I'm going to probably want to rewrite everything in terms of sine and cosine, because A, I have to get it to be in terms of sine anyway, and B, it's just kind of messy if you don't think about it like that. Okay, so now that I have that, I'm going to get a common denominator of the denominators. And then the only thing I need is to change this 1 into a cosine squared over cosine squared. So now I have sine squared over cosine squared in the numerator, and I have sine squared plus cosine squared over cosine squared in the denominator. Um, I have a common denominator of the denominators, so that complex fraction simplifies to be sine squared over sine squared plus cosine squared. Sine squared plus cosine squared is 1, so the numerator is just sine squared x, and that is exactly the right-hand side. Real quick, I actually didn't have to do that if I know my trig identities really, really well, because tangent squared plus 1 is secant squared. Now, tangent squared is sine squared over cosine squared, and secant squared is 1 over cosine squared. The cosine squareds end up canceling out, and I get sine squared of x that way. So I just showed you that you could have done that problem in 2 different ways. And some problems, it's very possible to prove or verify them using multiple slightly different methods, and you end up with the same result. On problem 4, I'm going to work with the left-hand side. The reason why I'm going to work with the left-hand side is, well, I really don't have to, but I'm going to. Um, one thing I notice is that I have a 1 minus sign, and my goal is going to be to get a 1 plus sign in the denominator going to the right side. So I can multiply by the conjugate in both the numerator and denominator. And that ends up doing a couple things for me. First of all, I know that I need to have that in the denominator anyway. And second of all, if I multiply by the conjugate, I know that I'm going to end up with some sort of like maybe 1 minus sine squared in the numerator. And that's going to help me figure out something when it comes to like a Pythagorean identity or something. So that's one way to do it. 1 minus sine squared is cosine squared. And then cosine squared over cosine. The cosine, one of them cancels in both the numerator and denominator. And now I'm left with exactly what is on the right-hand side. I could have done this. I'm going to do this pretty quick. Go back and rewind if you want to write things down and I went too fast. But I'm going to go from now doing the right-hand side first. And so if I want to do the right-hand side first, what I can do is I can multiply by the conjugate in both the numerator and denominator right away. I end up with cosine of x times 1 minus sine of x in the numerator, and I have 1 minus sine squared of x in the denominator. And that ends up being cosine squared in the denominator minus sine x. And one of the cosines cancels, and I end up with everything that is on the left-hand side doing it that way. So I just wanted to show you that sometimes it's very possible to not choose the way that the teacher chooses in terms of like left-hand side and right-hand side, and you can still absolutely get the right answer very easily. Problem 5, I dare you to try and choose the right-hand side. But you absolutely can if you kind of know what you're doing. I'm going to choose the left-hand side because it's more complicated. So if we take a look at this problem, this is a factoring problem. So if I look at the numerator, if I had a problem, x squared plus 4x plus 3, and I was told to factor it, that hopefully wouldn't be a problem for us. That wouldn't be that much of an issue. It'd be x plus 3, x plus 1. Well, I'm just basically replacing all of those x's with sine of x. So this is sine of x plus 3 times sine of x plus 1 over cosine squared. So I just factored the numerator. Cosine squared, um, well, I can kind of take a hint from the right side. I'm going to need something to look like 1 minus sine. So I'm going to rewrite cosine squared as 1 minus sine squared, which is a Pythagorean identity. And this is starting to take shape, because now what I can do to the denominator is factor it into 1 minus sine x and 1 plus sine x. And this is going to end up working out really well in our favor, because those cancel out, and I can use the commutative property of addition to put 3 plus sine x in the order that it wanted me to have it for the right-hand side. And now I'm done. So in this problem, it was nice because you see that you actually have to use factoring with quadratics. That's something that might actually happen. The last problem, I'm going to work with the left-hand side. If I take a look at this, probably the first thing that I'll want to do is get a denominator, like figure out what to do to get the conjugate of the denominator. So cosine of x over 1 minus sine x, I'll multiply by 1 plus sine x in both the numerator and denominator. So that gives me cosine x times 1 plus sine x divided by 1 minus sine squared. Now 1 minus sine squared, one of the tempting things that sometimes people do, and I'm going to write this in red, you do not have to write this down, I'm just kind of showing you what happens sometimes. So I have the 1 minus sine squared, and I think, oh, well, maybe I should factor this into 1 minus or 1 plus sine, 1 minus sine. And then I end up canceling those, and then I realize that I just got back where I started. Um, you know, you have to be careful to make sure that you don't do things that you actually already just did. Your goal is to get to something new. So our goal, once again, is to get to secant plus tangent. So that's our objective. And in order to get to secant plus tangent, I have to keep a plus sign in the problem. And one way, I mean, we have to keep going, but 1 minus sine squared, that is cosine squared, and we know that from the many times we've done it. But if I recognize that, this is going to end up being pretty straightforward. Now I can cancel off one of the cosines, so I end up with 1 plus sine x over cosine x. And I can keep going now. This looks like I might be at a dead end, but remember, if I have the denominator as one term, then I can separate the numerator and keep the denominator in the same spot, or keep the denominator in both terms. So I have 1 over cosine plus sine over cosine. 1 over cosine is secant x, and sine over cosine is tangent x. And that's exactly the right-hand side.